Welcome to my Introduction to Networking course, also known as ITN. This is the version 7 material preparing learners for the Cisco CCNA 200-301. Cisco curriculum, everything is owned and copyrighted by them. Lastly, we have our switching speeds and forwarding methods. There are two major types of forwarding methods, store and forward and cut through. Store and forward basically will take the entire frame and check it against errors. This is slow and causes a delay. Cut through will actually look at the start of the frame. Once it receives its destination portion of its MAC address, it will start forwarding it out from there. It will not check for errors. Cut through actually cuts down on latency, because there are certain technologies that latency may cause an issue, like VoIP. Anything that requires real-time traffic, store and forward just makes this delayed. So there are issues there. However, an advantage over store and forward is that if it catches an error, because it will take the entire frame, check for errors, if there is an error, it will fix it early on. Where store and forward may actually forward on frames that are actually errored out and not functioning. So there are pros and cons between both of them. So there are some caveats to both of these. So in cut-through switching, the switch will act upon the data as soon as it's received. Again, the issue with this is it may forward on data that is corrupt. So there are two variants of cut-through switching, fast-forward and fragment-free. Fast-forward switching basically offers the lowest level of latency by immediately forwarding a packet after reading the destination. Fragment-free comprised between the high latency and high integrity of store and forward, and it tries to focus on the lower latency and reducing the integrity. So what it does is it looks at the first 64 bytes of the frame, because typically that is where the most amount of errors would occur. So there is some give and take. When a switch is overly congested and there is no way to forward on data, there are two things that can happen. The switch can either drop the frame or it can hold it in its memory. If it holds it in its memory, there's two types of memory it can hold it in, port-based or shared-based. In the port-based memory, basically each port will have a query, a queue, and as data is being lined up to send, it has to wait for the preceding data to actually get there before it can send. If it is shared, the entire switch will actually share data, and the switch will compile the data at a level to send out data. Again, with port-based, the data that was there first has to be sent, and then it will send the next group of data, and then the next, based off of per port. We've already talked about duplex and a little bit, so we know full duplex is send and receive simultaneous. Half duplex is one or the other. We know that gigabit has to be full duplex. So let's go ahead and talk about speed. Speed can be done either manually or can auto-negotiate. So with speed, we have the ability to set either 10, 100, 1000 megabits per second and so forth. The auto-negotiate portion has to be there so that both sides of the cable can figure out what speed to operate, just like within our full duplex versus half duplex. Both sides have to operate at the same time, so that auto-negotiation can actually set duplex and our speed. It just kind of depends on our functionality. What are we trying to accomplish? One of the last major things we have to talk about while talking about switching is this auto MDIX. With auto MDIX, it will take what is a standard cable, a straight through cable, and it allows us to connect two switches. Normally, like devices would use a crossover connection. However, Auto MDIX can actually flip one side of the connection to ensure communication can flow. And that is this chapter in a nutshell. If you have any questions or concerns, please reach out.